In question 1, we're asked to use our calculator to work out the value of the square root of 208.3 minus 15.7 and all divided by 5.694 plus 1.8 squared. And we are asked to write down all the digits on the calculator display. So I'm going to go on my calculator here. I press the square root. We're looking at a fraction. In the numerator, we've got 208.3 and we've got minus 15.7. And in the denominator, we're looking at 5.694 plus the 1.8 to the power of 2. I press the equal sign. That's the answer we get here. So as the final answer, we are putting 4.643069317, which is the full calculator display. In question 2, the scatter graph shows information about some ships. It shows the length and the width of each ship. We can see that the length appears in the horizontal axis, it's given in meters, and the width appears on the vertical axis and it's also given in meters. And we are asked what type of correlation do we see in this scatter graph. Well, we see that as the length increases, the width also increases, so we conclude that we're looking at positive correlation. In part B, we're asked to draw a line of best fit on the scatter graph, so we need to draw a straight line that is as close as possible to the points here. So it's something along this line here. So I draw my line of best fit. Make sure you extend it at least up to the minimum point and the maximum point so it covers all the data observed here. A different ship has a length of 194 meters, and we're asked to use our line of best fit to find an estimate for the width of this ship. So going on the scatter plot, we go at 194 for the length, and we go to the left and we read off the width, which is 28. So the final answer for part C is that we expect 28 meters to be the width of a ship which has a length of 194 meters. In question 3, we're given that in London a 200 grams of chocolate bar is costing £3.50, while in Zurich 360 grams of the chocolate bar is costing 7.20 Swiss francs. Now the exchange rate is £1 for 1.25 Swiss francs, and we are asked in which city is the chocolate bar the better value for money, whether it's London or Zurich, and we must show how we got our answer. So we need to find a way of making these two prices to be comparable. So the first thing to do is say that if we've got £1 to correspond to 1.25 Swiss francs, let's convert the £3.50, which is the price of the chocolate bar in London, into francs. So 3.50 is X Swiss francs. So I'm doing cross multiplication here. So I'll be doing 3.5 times 1.25 divided by 1 to get the value of X. So we're looking at X to be 3.50 times 1.25 and all divided by 1. This gives an answer of 4.375, which is the price for a chocolate bar weighing 200 grams in London, and this is the price in Swiss francs. I will then change the masses, so I'm gonna say we've got 360 grams costing 7.20 in Zurich, and how much will 200 grams cost? So 360 grams corresponds to 7.20 Swiss francs, so 200 grams is corresponding to Y Swiss francs. Once more, I'm doing cross multiplication here, so to find Y, I'll be doing 200 times 7.20 and all divided by 360. If I evaluate this, I get an answer of 4, and we can see that for the same weight of the chocolate bar, we need to pay more in London. We need to pay 4.375 Swiss francs compared to the 4 francs we need to pay if we are in Zurich. So all we need to say is that 4 is less than 4.375, and therefore we conclude that the chocolate bar is a better value in Zurich. In question 4, the universal set is consisting of the odd numbers between 0 and 20. Set A consists of 3, 9, 15, and 17, while set B consists of 5, 7, 11, 13, 17, and 19. Now, Tom was asked to draw a Venn diagram for this information. This is the answer. This is the Venn diagram that Tom drew. and we are asked to write down two things that Tom should do to make his answer fully correct. Well, the first thing we observe is that the number 1 is missing from this Venn diagram. Now, the number 1 is not an element of A or B, so it should appear outside of A and B. So the first thing I'm noting down is that the number 1 should be placed outside of A and B. Secondly, we observe that 17 has been listed twice, once in the intersection between A and B, and a second time in the only A region. Well, 17 is a common element to both A and B, so it should appear in the intersection, but it should not be listed for a second time within A. So the second point we're raising here is that the number 17 should only appear in the intersection of A and B. In 5a, we're asked to complete the table of values for y is x squared minus 2x minus 3. So we've got x values from -2 up to 4, every one. So I'm going to go on my calculator here. I press menu, it's option 9 table. My f of x is x squared minus 2x minus 3. I press the equal sign. I leave g of x empty, so I press the equal sign again. I'm starting at -2. We are ending at 4. We are stepping every one. So here the calculator has produced all corresponding y values from x is -2 up to x is 4. So we can see, for example, that when x is -2, y is 5, then it's 0, then it's -3, -4, and so on. So I can simply go back to the table here and fill in the missing values. So we've got the completed table of values, and we can therefore proceed into part B, where we are asked to draw the graph of y is x squared minus 2x minus 3 for values of x from -2 up to 4. So I start by plotting the points for which we have coordinates from the table above, and I join them with a smooth curve to complete the answer to part B. In question 6, the cost of a first class stamp increased from 76 pence to 85 pence, while the cost of a second class stamp has increased from 65 pence to 66 pence, and Philip says that the percentage increase in the cost of a first class stamp is more than 7 times the percentage increase in the cost of a second class stamp, and we need to assess whether Philip is correct, and we need to be showing all of our working. Well, I will start by reminding ourselves that the multiplying factor is given by the final amount divided by the original amount. So starting with the first class stamp, we went from 76 to 85 pence. So I will be doing 85 divided by 76. I run this on the calculator. I get an answer of 1.11842 ... and this corresponds to an increase of 11.84%. So I'm writing here 11.84% increase. To see the percentage increase, I read off the numbers after the decimal point. So I ignore the 1 here. The fact that the overall multiplying factor is greater than 1 means we're looking at an increase. Then we see the 11.842 ... So we're looking at 11.842% of an increase. Now I'm going to do the same for the second class stamp. We went from 65 to 66. So I'll be doing now 66 divided by 65. If I run these numbers on the calculator, I get 1.01538 ... and we are therefore looking at 1.54% increase for the second class stamps. Now the claim by Philip is that the percentage increase in the first class stamp is more than 7 times the percentage increase for the second class stamp. So I'll be doing 11.84 ... which is the percentage increase for the first class stamp, divided by 1.54 ... which is the percentage increase for the second class stamp. This gives an answer of 7.697 ... which is greater than 7, and therefore we conclude that Philip is correct. In question 7, the diagram is showing triangle ABC. Now all measurements are in centimeters, and AC and BC are equal in length. Now the perimeter of the triangle is 72 centimeters, and we need to work out the area of the triangle. So first of all, we need to find a way of setting up an equation and solving to find the value of x. One way is to use the fact that we're looking at an isosceles triangle, and therefore AC is equal to CB. Alternatively, I could use the fact that we've got the perimeter of the triangle to be 72 centimeters, and therefore add up the three expressions for the three lengths of this triangle and set the total to be equal to 72. So I will start by setting AC and CB to be equal. This means that we're looking at 2x plus 11 being equal to 4x minus 4, and therefore 11 plus 4 is equal to 4x minus 2x, which means that 15 is equal to 2x, and therefore 15 over 2 is the value of x. Now, based on this value, I will proceed in finding the lengths of the sides, the length of AC, the length of CB, and the length of AB. So starting with AC, we're looking at 2x plus 11, which is equal to 2 times 15 divided by 2, which is the value of x, plus 11. So we're looking at 15 plus 11, which gives an answer of 26. And then for 2x plus 5, we're looking at 2 times 15 divided by 2 plus 5. So we're looking at 15 plus 5, which gives an answer of 20. And therefore, going back to the diagram provided, AC is 26, CB is also 26 because the triangle is isosceles, AB is equal to 20, and what I can do here is drop the perpendicular from C onto the base AB here. We know that the angle at the base will be a right angle, and if we drop the perpendicular from C onto the base AB, given that the triangle is isosceles, we have bisected the base, so this distance here is exactly 10 centimeters. We're trying to find the height, which I call h, in order to proceed and find the area of the triangle. So I'm now looking at the triangle here. It's a right angle triangle, and I can use Pythagoras theorem. We're looking at 26 squared, which is the hypotenuse raised to the power of 2, being equal to h squared plus 10 squared, and therefore 26 squared minus 10 squared is equal to h squared. I will simply take the square root of 26 squared minus 10 squared to find the value of h, which is the height of the triangle. This turns out to be 24 centimeters. So we've got the base, we've got the height. We know that the area of a triangle is given by base times height over 2. So I'll be doing here 20 times 24 divided by 2. If I plug this on the calculator, I get an answer of 240, and therefore we conclude that the area of the triangle is 240 square centimeters. In question 8, we're given 1.25 times 10 to the negative 12 being equal to k times 4 times 10 to the negative 20, and we're asked to work out the value of k, giving our answer in standard form. Well, the first thing to do is isolate k, so we're looking at 1.25 times 10 to the negative 12 divided by 4 times 10 to the negative 20 being equal to k. And then I'll be doing numbers with numbers, so 1.25 divided by 4, and then powers of 10 with powers of 10, so 10 to the negative 12 divided by 10 to the negative 20. Well, 1.25 divided by 4 is 0.3125, and then when we've got division with a common base, we subtract the indices, so we're looking at 10 to the negative 12 minus the negative 20, and all of this is equal to k. So all in all, we've got 0.3125 times 10 to the 8 being equal to k. Well, the question is asking me to give my answer in standard form. So I will multiply the 0.3125 by 10 to give me 3.125. And to counterbalance the effect of multiplying by 10, I'm deducting 1 from the power of 10. So that's times 10 to the 7. That's the value of k. So all in all, we conclude that k is equal to 3.125 times 10 to the 7. In question 9, the diagram shows two congruent regular 9-sided polygons. ABCD is a quadrilateral, and we're asked to show that ABCD is not a square. So I will start by concentrating here. I'll be looking at the interior angles of the regular 9-sided polygon and the interior angle of this quadrilateral here. If this is indeed a square, we expect angle ABC to be 90 degrees. So the plan is for me to calculate the size of the angle ABC, and I'm hoping to get an answer which is not 90 degrees, and therefore this will allow me to conclude that ABCD is not a square. So starting with these angles here, we've got theta being the interior angle of the regular 9-sided polygon on the left, and so is the angle here on the right. I'm calling phi to be the angle ABC, and I will proceed by reminding ourselves that the sum of the interior angles of a polygon is given by n minus 2 times 180, where n is the number of sides. Well, we're looking at 9-sided polygons, so I'll be doing 9 minus 2 times 180. This gives an answer of 1260. So to find the size of the angle theta, I simply need to do 1260 divided by 9, because we know that in regular polygons, all interior angles are of the same size. Well, theta turns out to be 140 degrees. And I can therefore proceed by considering that theta plus phi should give me a result of 360, because we're looking at angles at a point. So let me start by stating here that theta plus phi is equal to 360 degrees. Well, we're constructing a proof here, so we need to state the reason. Angles at a point add up to 360 degrees. We have found theta to be 140 degrees, so I'm doing 140 plus 140 plus phi to be equal to 360, which leads to 280 plus phi to be equal to 360, which means that phi is equal to 80 degrees. Well, surely this means that we're not looking at a square, because we said that the interior angles of a square are all 90 degrees. So all I need to write here is a conclusion, and I say that since phi is not equal to 90 degrees, then ABCD is not a square. In question 10, we're asked to use algebra to solve the simultaneous equations 4x minus 5y is 20 and 6x plus 7y is negative 57, showing all of our working. Well, the first thing to do is label the two equations. We've got equation 1 and equation 2. The plan is for me to use elimination here. So I will take the first equation and multiply by 3. So we're looking at 12x minus 15y being equal to 60. And I will take the second equation. So I'm going to do 2 times 2. So I'm multiplying everything by 2 in the second equation. This leads to 12x plus 14y being equal to negative 114. And we can see that upon deducting one from the other, we will be eliminating the 12x, because 12x minus 12x is 0. We've got then negative 15y minus the 14y. So we've got negative 29y being equal to 60 minus the negative 114, which gives an answer of 214, and therefore y is equal to 214 divided by negative 29. This evaluates to negative 6, so y is negative 6. So I can go back to any of the equations to find x. So I can go to the first equation here. We're looking at 4x minus 5 times y, which was found to be negative 6, being equal to 20. So 4x plus 30 is equal to 20, which means that 4x is equal to negative 10. And if I divide both sides by 4, we get that x is equal to negative 5 divided by 2. And therefore, we conclude that the final answer to question 10 is that x is negative 5 over 2 and y is negative 6. In question 11, we're given triangles A and B, and we're asked to describe fully the single transformation that will map triangle A onto triangle B. Well, the first thing we observe is that the size of A and the size of B are different, so we're surely looking at an enlargement, because that's the only transformation that can affect the size of the object compared to the image. Now, A is the starting point, A is the object, B is the final, that's the image. When I'm describing an enlargement, I need to determine the scale factor. as well as the center of the enlargement. So starting with the center of the enlargement, I'm determining points that correspond on the object and the image. So for example, these 2 points, and I'm joining them together with rays of light. So I'm looking at something like this. The point at which these rays of light intersect is giving me the center of the enlargement. This obviously having coordinates -4, -2, and I then proceed in finding the scale factor. We know that the scale factor is given by the image divided by the object. Well, the object is A and the image is B. I'm getting corresponding distances on the object and the image. So for example, if I consider these distances here, we can see that the distance of 3 on A became 2 on B. So the scale factor will simply be 2 divided by 3. And therefore, we can now proceed into describing this transformation. We're looking at an enlargement with a scale factor of 2/3 and center the point -4, -2. In question 12, the diagram shows a solid cylinder with a base radius of 3 centimeters and a height of 8 centimeters. It also shows a solid cube with side length 8 centimeters, and the cylinder is made from steel with a density of 7.86 grams per cubic centimeter, while the cube is made from brass with a density of 8.5 grams per cubic centimeter. Now the mass of the cylinder is equal to the mass of the cube, and we're asked to work out the value of H, giving our answer correct to 1 decimal place. The first thing to do is label the 2 solids as A and B. We know that the density is given by mass divided by volume, and since we're looking at a cylinder here, let's remind ourselves that the volume of a cylinder is given by pi r squared h. So the volume of A is given by pi times 3 squared times the height of 8. So the volume of A is equal to 72 pi cubic centimeters. I will proceed in finding the mass of this cylinder. So I'm doing density of 7.86 being equal to the mass m divided by the volume of 72 pi. I will cross multiply. 7.86 times 72 pi is 1,777.89 ... That's the mass of the cylinder in grams, and we know that the cube has exactly the same mass. Well, let's look at the cube now. The volume of the cube B is simply h cubed, and therefore the density, which is 8.5 grams per cubic centimeter, is equal to the mass, which is 1,777.89 ... divided by h cubed. So we're looking at 8.5 h cubed being equal to 1,777.89 ... I'll be dividing both sides by 8.5, so we're looking at h cubed being equal to 1,777.89 divided by 8.5, and I will proceed by taking the third root of this to find the value of h. So we're looking at 1,777.89 to be divided by 8.5, and we take the third root of this. Well, if I plug this on the calculator, we get that h is equal to 5.936 ... And therefore we'll conclude that correct to 1 decimal place, h is 5.9. In question 13, we're given a table of values of x and y. So we can see, for example, that when x is 2, y is 0, when x is 4, y is 4, and so on. Now, Nadia says that y is directly proportional to x because the value of y increases by 4 as the value of x increases by 2. And we are asked whether Nadia is correct, giving a reason for our answer. Well, we know that 2 quantities are directly proportional if their ratio is always the same. So if x and y are directly proportional, then x over y is equal to k, where k is a fixed number. Well, we can see, for example, that 4 over 4 is 1, and 6 over 8 is 3 over 4. And since 1 is not equal to 3 over 4, then Nadia is wrong. W is directly proportional to the square root of t, and W is 140 when t is 64, and we're asked to calculate the value of W when t is 7.84. Well, since W and the root of t are directly proportional, this means that W divided by root t is equal to a constant k. I'll be substituting W with 140, and t with 64. So 140 divided by root 64 is equal to k, and this gives me that k is 35 divided by 2. I can therefore write down the relationship between w and root t. We've got w divided by root t to be equal to 35 divided by 2, and I can now cross multiply to get that w is 35 divided by 2 times the square root of t. I will now substitute t with the value of 7.84 given here. So w is equal to 35 divided by 2 times the square root of 7.84. When evaluated, this gives an answer of 49, and therefore we conclude that w is equal to 49. In II, we need to sketch a graph to show the relationship between w and t on the axis below. Well, we have established that w is 35 over 2 root t, so we're looking at a graph that resembles a square root graph, and therefore we're expecting to see something like this. In question 14, we've got 10 football teams in a league. Now each team plays every other team 4 times, and we need to work out the total number of games played. Well, the first thing to realize is that each team has 9 opponents, so let's find the number of games to be played. I'll be doing 10 times 9 divided by 2. This gives me the total pairs, so each of these 10 teams has 9 opponents to face, so 10 times 9. I'm dividing by 2 because I don't want to be counting A playing B and B playing A as different games. And then we've got every team facing each other a total of 4 times, so I will multiply this by 4. If I evaluate this, I get an answer of 180, and therefore the final answer to 14 is that we expect to get 180 games in total to be played. In question 15, we're given the first 5 terms of a quadratic sequence. Well, it goes 3, 20, 47, 84, 131. And we're asked in part A to find an expression in terms of n for the nth term of this sequence. Well, let me start by stating that the nth term un is given by an squared plus bn plus c. It's a quadratic sequence, that's why we've got an n squared term appearing, and a, b, and c are constants to be determined. Well, we know that the first term u1 is equal to 3, so if I substitute n is 1, get a times 1 squared plus b times 1 plus c. So we're looking at 3 being equal to a plus b plus c. Then u2, the second term, is 20, so it's a times 2 squared plus b times 2 plus c. So we're looking at 20 being equal to 4a plus 2b plus c. And finally, for the third term, u3, this is equal to 47, and this is given by a times 3 squared plus b times 3 plus c. So 47 is equal to 9a plus 3b plus c. So we're looking at 3 simultaneous equations in 3 unknowns. I will start by considering the first and the second one. I'm deducting one from the other. So 20 minus 3 is 17. 4a minus a is 3a. 2b minus b is b, and the c's will cancel out. And then I'm considering the second equation with the third equation. So 47 minus 20 is 27, which is equal to 5a. That's 9a minus 4a plus b, and the c also cancels out. So I have now reduced the 3 simultaneous equations in 3 unknowns into 2 simultaneous equations in 2 unknowns. I combine these two together. I'm doing 27 minus 17, which gives me 10, which is equal to 5a minus 3a, which is equal to 2a, and the b's cancel out, and therefore we conclude that 5 is the value of a. I will now go back and find the value of b. So 17 was equal to 3a plus b, so 17 is 3 times 5 plus b. So we're looking at 17 being 15 plus b, which means that 2 is the value of b. And then using the fact that a plus b plus c is 3, I will determine the value of c. So 3 is equal to a, which is 5, plus b, which is 2, plus c. So 3 is equal to 7 plus c, which means that negative 4 is the value of c. and we can therefore write down that the nth term is given by 5n squared plus 2n minus 4. The terms of a different sequence are given by the rule un plus 1 is k un plus k, where k is a constant. Additionally, we're given that the first term is 9 and the second term is 4, and we're asked to determine the value of u4. So what this is telling me here is that the next term is k times the previous term plus k. So for example, u2 will be equal to k times u1 plus k. We've got u2 to be 4, we've got u1 to be 9, so 4 is 9k plus k, taking me to 4 being equal to 10k, and therefore 0.4 is the value of k. I will then proceed in finding u3 and then u4. So u3 is equal to k times u2 plus k. So u3 is equal to 0.4 times 4 plus 0.4, which means that u3 turns out to be equal to 2, and therefore u4 is equal to k times u3 plus k, and therefore we're looking at u4 being equal to 0.4 times 2 plus 0.4. This leads to u4 being equal to 1.2, and therefore the final answer to part B is that u4 is equal to 1.2. In question 16, we've got the histogram giving information about the distances that 60 teachers traveled to school on Monday. Now the histogram is incomplete. We are told that 11 of the teachers have traveled between 0 and 5 miles, and none of the teachers traveled a distance greater than 50 miles. Now the number of teachers that travel between 5 miles and 10 miles is the same as the number of teachers that have traveled between 20 miles and 30 miles. And we're asked to complete the histogram here. Well, let's start by reminding ourselves that in a histogram, the frequency density is equal to the frequency divided by the class width. So obviously multiplying the frequency density by the class width will give me the frequency. So if I concentrate on this first bar here, we can see that it has a height of 2.2, it has a base of 5. If I do 5 times 2.2, so if I do class width times the frequency density, we get an answer of 11, which matches the fact that 11 of the teachers travel between 0 and 5 miles. So we've got 11 teachers here. I can therefore proceed into finding the number of teachers traveling between 10 and 20 miles, and then traveling between 30 and 50 miles. So for the 10 to 20, we've got a base of 10 and a height of 1.5. So if I do 10 times 1.5, we get an answer of 15. And for the 30 to 50, we've got a class width of 20 times a height, a frequency density of 0.3, which gives an answer of 6. We know that in total we had 60 teachers, so I will be doing 60 minus the 11 plus the 15 plus the 6. This gives an answer of 28. And since we are told that the number of teachers that travel between 5 and 10 miles is the same as the number of teachers that travel between 20 and 30 miles, all I need to do is do 28 divided by 2, which is equal to 14. So I've got 14 teachers traveling between 5 and 10, and 14 teachers traveling between 20 and 30. So I will do 14 divided by the class width of 5. This gives an answer of 2.8. That's the frequency density for the 5 to 10 class. And then 14 divided by 10, which is equal to 1.4. That's the frequency density for the second class between 20 and 30. And I can therefore proceed into simply adding the two bars, the one between 5 and 10 going up to a height of 2.8, and the one between 20 and 30 going up to a height of 1.4 to complete the histogram. In question 17, we're asked to show that 6x minus y over 10xy plus 1 over 2x minus 2y minus 7x over 5xy simplifies to k over y, where k is an integer. So starting with what we're given, the first thing to do is identify that the LCM here is simply 10xy. So the first fraction will be multiplied by 1 because the denominator is already the LCM. The second fraction will be multiplied by 5y, and the third fraction will be multiplied by 2. So all in all, we're looking at 6x minus y plus 5y minus 2 times 2y minus 7x, and all divided by 10xy. I will proceed in expanding the numerator, so we've got 6x minus y plus 5y minus 4y plus 14x, and all divided by 10xy. So looking at the numerator here, we can see that negative y with negative 4y and 5y will cancel out. So we are left with 20x divided by 10xy. Obviously the x will cancel out, and then the 20 with the 10 will leave me a 2 in the numerator. So we conclude that this expression simplifies to 2 over y, and we therefore have that k is equal to 2. In question 18, we've got A, B, and C being 3 points on a circle centered at O. We're additionally given that BA is equal to BC, and we need to prove that OB bisects angle ABC. So the idea here is for me to show that we're looking at congruent triangles, and therefore this will lead to the conclusion that OB is bisecting the angle ABC. So the first thing to do is draw the radii from O to A, B, and C. We are given that BA is equal to BC, and we can also state that OA, OB, and OC are all equal in length because they are radii of the same circle. This means that we're looking at congruent triangles. The triangle OAB and the triangle OCB are congruent because we've got 3 corresponding sides being of the same length. And since the 2 triangles are congruent, then surely the angle CBO and the angle ABO are equal. So the theta here corresponds to angles of the same size, and therefore we can see that OB is cutting the angle ABC in 2 equal angles. Therefore we conclude that OB bisects the angle ABC as required. In question 19, we've got that T is W over A minus C. Now W is 435, correct to the nearest 5. A is 9.8, correct to 2 significant figures. And C is 2.5, correct to 2 significant figures. And by considering bounds, we need to calculate the value of T to a suitable degree of accuracy, showing all of our working and giving a reason for our final answer. Well, I will start with the fact that we're given W, A, and C to certain degrees of accuracy. So starting with W, we've got W being 435, correct to the nearest 5. So I'm going to go 2.5 up to find the upper bound for W. That's 437.5. And I'm going to go down 2.5. So 435 minus 2.5, which gives an answer of 432.5. That's the lower bound of W. I will then proceed for A. We've got A is 9.8, correct to 2 significant figures. So that's 9.85 for the upper bound and 9.75 for the lower bound. And then for C, C was given to be 2.5 to 2 significant figures. So the upper bound will be 2.55 and the lower bound will be 2.45. The plan is for me to determine the upper bound and the lower bound of T and compare the two. So for the upper bound of T, I'll be maximizing the numerator. So I'm taking the upper bound of W, which is 437.5, and then I'm considering the lower bound of the denominator. So to make the denominator here as small as possible, I will make A as small as possible and C as big as possible. So I'm taking the lower bound of A, which is 9.75, and I'm deducting the upper bound of C, which is 2.55. If I evaluate this, I get an answer of 60.763888 ... That's the upper bound of T. And I will proceed in finding the lower bound for T. So I'm taking the lower bound of the numerator, which is 432.5. And in the denominator, I'm trying to make A minus C as large as possible. So I'm taking the upper bound of A and I'm deducting the lower bound of C. So I'll be doing 9.85 minus 2.45. When this is evaluated, we get an answer of 58.44594 I can see that if I was to round both the upper bound and the lower bound to one significant figure, they will both give me the same answer of 60. However, if I was to round this to 2SF, the upper bound will give me 61 and the lower bound will give me 58. So we've got a disagreement. So all I need to say here is that since the upper bound and the lower bound are rounding to 60, correct to 1SF, but they do not agree to 2SF, then T is 60. That's the suitable degree of accuracy. So my final answer to question 19 is 60. In question 20, we've got VABC, which is a solid pyramid. Now ABC is an equilateral triangle. M is the midpoint of AB and F is the point on MC, such that MF to FC is 1 to 2. Now the vertex V is vertically above F, and VA, VB, and VC are all equal in length. Additionally, VF is 8 centimeters and the angle VCM is 52 degrees. And whereas to work out the side length of the equilateral triangle ABC, giving our answer correct to one decimal place. So I will start by highlighting the triangles within which I'll be working for this question. We've got the triangle VFC. It's a right angle triangle because the vertex V is vertically above F. The distance VF is given to be 8 centimeters and the angle VCM is 52 degrees. Additionally, we are given that the ratio of MF to FC is 1 to 2. So MF is a third of MC and FC is 2/3 of MC. The second triangle, which I'll be focusing on later, is the triangle MCB, shown shaded in red. So I will start by extracting the triangle VFC. I'm trying to find the length of FC. I'm using SOHCAHTOA. So I'm using that tan of 52 is equal to 8, which is the opposite, divided by FC, which is the adjacent. So we've got FC tan of 52 being equal to 8, and therefore FC is equal to 8 over tan of 52. So now that we've got the size of FC, I will proceed. We've got that FC is 2/3 of MC. So I can replace FC with 8 over tan 52 that we just found. So 8 over tan 52 is equal to 2 over 3 MC. I will proceed by multiplying both sides by 3 over 2. So 3 over 2 times 8 over tan of 52 should be equal to the length MC. If I evaluate this on my calculator, I get 9.375427 for the length of MC. And I can therefore proceed by considering the right angle triangle CMB. We just found the side CM to be 9.37 and we're trying to determine BC. We know that the angle MBC is 60 degrees because ABC is an equilateral triangle and therefore the angle B here should be 60 degrees. So I will proceed by stating that sine of 60 is equal to the opposite, which is 9.37 divided by the hypotenuse, which is BC, and therefore BC sine of 60 is equal to 9.37 leading to BC being equal to 9.37 divided by sine of 60. If I go on my calculator and evaluate this, I get that BC is equal to 10.8258 and we therefore conclude that the length of BC is 10.8 centimeters, correct to one decimal place. In question 21, we've got the point P with coordinates -4,5, the point Q with coordinates 6, -6, and the point R with coordinates K, K plus 3. We're given that PRQ is a right angle and we're asked to determine the possible values for K, showing all of our working. Well, the first sensible thing to do is draw a quick diagram. We've got the 3 points PRQ. We are told that PRQ is a right angle, and I'll be considering gradients for PR and RQ. Well, we know that the gradient is given by y2 minus y1 over x2 minus x1. So starting with the gradient for PR, I'm doing k plus 3 minus 5 divided by k minus the negative 4, which gives an answer of k minus 2 over k plus 4. And I then proceed with the gradient of QR. This is equal to k plus 3 minus the negative 6 divided by the k minus 6, which is equal to k plus 9 divided by k minus 6. And we know that if two lines are perpendicular, then the product of their gradients is negative 1. This simply means that the gradient of PR times the gradient of QR should be equal to negative 1, and therefore k minus 2 divided by k plus 4 multiplied by k plus 9 divided by k minus 6 should be equal to negative 1. So I will proceed by expanding the numerator. We're looking at k squared plus 9k minus 2k minus 18. And in the denominator, we're looking at k squared minus 6k plus 4k minus 24. And this is equal to negative 1. So we've got k squared plus 7k minus 18 in the numerator. And in the denominator, we're looking at k squared minus 2k minus 24. And the result is negative 1. I will proceed by cross multiplying. So we've got k squared plus 7k minus 18 being equal to negative k squared plus 2k plus 24. And if I collect everything on the left hand side, we're looking at 2k squared plus 5k minus 42 is equal to 0. So we're dealing with a quadratic in k. This factorizes into 2k minus 7 times k plus 6. So we conclude that 2k minus 7 is equal to 0, or alternatively, we've got that k plus 6 is equal to 0. So 2k is equal to 7, which means that k is equal to 7 over 2, or alternatively, k is negative 6. So all in all, we conclude that k can attain two possible values. Either k is 7 over 2 or k is negative 6. In question 22, we are told that there are only red counters and yellow counters in a box. Now 3/5 of the counters are red, and Sophie takes at random 2 counters from the box. Now the probability that the 2 counters are the same color is 41 over 80, and we are asked to work out the number of yellow counters in the box, showing all of our working. Well, the first thing to do is say that suppose we originally had R red counters and N counters in total. And I'll be approaching this question by considering a tree diagram. So the first draw will give me a red or a yellow counter. We've got R red counters out of a total of N counters. So that's the probability of R over N. And the probability of getting a yellow counter is obviously N minus R divided by N. Well, we were given that the probability of drawing a red counter on the first draw is 3 over 5. So R over N is equal to 3 over 5, which means that N minus R over N is simply 2 divided by 5. And we can proceed in considering the possibility of drawing 2 red or 2 yellow counters. So once we have drawn a red counter, the probability of drawing another red counter is simply R minus 1 divided by N minus 1, because we have drawn out the red counter. So we're left with R minus 1 counters, which are red, out of a total of N minus 1 counters. While if we draw first the yellow counter, we are now left with N minus R minus 1 yellow counters out of a total of N minus 1 counters. So the probability of red is given by 3 over 5 times R minus 1 divided by N minus 1. And the probability of yellow is given by 2 over 5 times N minus R minus 1 over N minus 1. And the sum of these two probabilities is given to be 41 divided by 80. I will proceed by multiplying throughout by 5 times N minus 1. This will give me 3 times R minus 1 plus 2 times N minus R minus 1 being equal to 41 divided by 80 times 5 times N minus 1. We can see that the 5 with the 80 will cancel out to leave me with 16 in the denominator, and on the left hand side I'm expanding to get 3r minus 3 plus 2n minus 2r minus 2 being equal to 41 over 16 times n minus 1. I will then collect the like terms on the left hand side. We're looking at r plus 2n minus 5 being equal to 41 over 16 times n minus 1, and I will now cross multiply with 16 to get 16r plus 32n minus 80 being equal to 41n minus 41. This leads to 16r being equal to 9n plus 39. So that's one relationship between r and n. At the same time, we know that 3 over 5 is equal to r over n. And if I cross multiply, we get 3n is equal to 5r. I will multiply throughout by 3 to get 9n is equal to 15r, which means I can replace the 9n here with 15r. So we're looking at 16r being equal to 15r plus 39. This means that r is 39, so we had 39 red counters originally. So 3n is equal to 5 times r, so 5 times 39, taking me to 3n is 195, which means that n is 65. So 65 is the total number of counters. Remember, the question is asking for the number of yellow counters, which is simply the difference between the total number of counters, which is 65, and the red counters, which is 39. So 65 minus 39 is 26. So all in all, we conclude that we have 26 yellow counters at the beginning.